Hi guys, Mrs. Pesic again. We are looking at logarithms continued. This is section 7.4, and in this section we're going to be looking at two special logarithms. The first one is the common log. That's just a logarithm with base 10. You can write it with a little base 10 there, log base 10, like this. But it's usually just written without a base. So if you see log without a base, you know that it's going to be base 10. All right, so let's take a look at an example. What's log of 100? Remember, that is common log because there's no base written here. But if you want to remember what the base is, you could write it in, but that 10 there is optional. If you don't see a 10 there, it's understood to be a base 10. So that's really saying 10 raised to what power is equal to 100? And what's it going to be? 2 it is. So log of 100 is equal to 2. How about this next example? How about log of 1/10? Notice common log because we don't see a number written here as the base. But if you don't see a number, it's understood to be a common log, base 10. So 10 raised to what power is equal to 1/10? That's going to be -1, because you remember negative exponents, 10 to the -1 is going to be 1 over 10 to the +1, which is 1/10. So our answer for this problem is -1. Our answer to the previous problem was 2. And I hope that you're completing your video guided notes for this video lesson also. All right, before we look at the other special logarithm, let's investigate an unusual number. And we're going to find this unusual number by looking at 1 plus 1 over n raised to the n. And the idea is we want to look at this expression here and see what happens as n gets very large. So we're going to look at what happens as n gets large. All right, that means if we pick out bigger and bigger values to plug in for n, like 100, 1,000, a million, what's going to happen to this expression 1 plus 1 over n to the n? I think you're going to see it's going to be a surprising result. So let's try this here. So if we're going to plug in 1 for this, we can go to our calculators and type it in. I'm going to do left parentheses 1 plus, I'm pulling up a fraction template, so I want 1 divided by 1 over 1. I'm trying 1 first, and then I want to close my parentheses. Whoops, no, I don't want to do that. And I want to okay, and then I want to raise that to the first power. So I'm using 1 as my n value, and I am getting 2 as my answer. So right here, I am going to fill in 2. All we did so far is we plugged in 1 for here and for here. So I did 1 plus 1 over 1 raised to the 1. Well, it makes sense. That's 1 plus 1 is 2. Raised to the first is 2. Let's see what happens if we plug in, that was not supposed to happen. There we go. Let me get rid of this. Cut. All right, so we're going to fill in 2 here. Now let's see what happens if we plug in 2 for the n and the n. That answer is going to go here. All right, so if we plug in 2, let's go back to the calculator and do that. And I'm actually going to just pop up 2 clicks, up clicks, and push enter to bring this down here. And I'm just going to fill in a 2 here. And I am going to fill in 2 here. And that is giving me, 2.25. So let's fill in 2.25 in our table. Right here, 2.25. So what we learned was if we have 1 plus 1 over 2 raised to the 2, then that's going to be 1 plus, that's 3 halves squared is 9 fourths, that's 2.25. Let's see what happens if we get our values bigger. So let's say now if we want to fill in tens for these n's, our answer is going to go in this column. So let's do that. Back to the calculator. So if we do that, again, I'm just going to do up click twice, pop it over here, left click. I'm fixing the 2's and changing them to 10's. All right, we're saying what if n is 10? All right, so I've got 1 plus 1 over 10 raised to the 10th. I'm getting 2.59 approximately. So let's fill in 2.59 in our table. 2.59. What about if we pick 1,000? If I plug in 1,000 for the n's, do you think our number is going to get really big? What do you think is going to happen? Well, let's try it. We're going here and we're going to, I'm doing 2 up clicks again. And I just want to change the tens to 1,000s. And if I do that, what is this number going to be? Oh, it's 2.717 approximately. So let's fill that in, 2.717. All right, what if we fill in 10,000? So let me add another 0 here and another 0 here. We're filling in 10,000s for the n. And let's test out that. Again, up click twice. And I'm going to fill in another 0 here and another 0 here. And I get this is approximately equal to 2.718. If you try bigger and bigger and bigger numbers, you're going to see that it's approaching one number that is approximately 2.78 something. So in other words, if you picked, you know, 1,000,000, it's going to be 2.7182 something something, but it's approaching 2.718. So as n gets large, 1 plus 1 over n to the n is approximately equal to 2.718. That number is so special, so important that it actually gets a letter. It gets a name. And that name is the letter E. So this is now not just letter E, it's number E. So as n gets large, 1 over 1 plus n raised to the n is approaching the number E. And again, that number E, when you think of the number E, I want you to be remembering that it is approximately equal to 2.718. That makes it a special number, kind of like pi is approximately equal to 3.14. They are both irrational numbers, but they're both real numbers. All right, so that leads us to the other special logarithm, which is a logarithm with base e, and it's called the natural log. If you remember, the log with the base 10 is common log, and log with the base e is called natural log. So we could write log with a little base e like this, but it's usually written ln for kind of log au natural. And so I hope you can see that that's an ln there. That's not in, that's ln. And so we would say ln of 1 is equal to what? Remember, that is the same thing as saying log to the base e of what? I'm sorry, log to the base e of 1 is equal to what? Well, e raised to what power is equal to 1? Well, that would have to be 0. So our answer here is going to be 0. ln of 1 is equal to 0. And what about ln of e? What's ln of e going to equal? Well, remember, we could think of it as ln of e, but we could always rewrite it as log to the base e of e. And that looks like one of those properties that we talked about in the last video lesson, which says if the bases are the same, it's just equal to 1. Why would it be equal to 1? Because this is really saying, if I'm going to translate this and write it in exponential form, e raised to what power is equal to e? Well, that would have to be 1. So ln of e is equal to 1. Okay, next up is how do we do logarithms on the calculator? So let's take a look at a few examples. Let's say we wanted to do ln of 0.25 on our calculator. So let's bring up the calculator. If I want to do ln, we have an ln button. It's right here above the e to the x. So you need to do second e to the x, and it pulls up ln, and we want it 0.25. And so that is going to be equal to negative 1.39 approximately, negative 1.39. All right, and what about log 7? Well, remember, this one here was a natural log. But this one here, since I don't see any base written here, it is a common log. And a common log means really think base 10. All right, so that means when we go to our calculator, we're really going to want to do log to the base 10 of 7. So let's try that. We have a log button that's right next to the ln button, but you do have to do control 10 to the x to get there. And so right here, it's giving you a place to type in your base. So we want base 10 of 7. And we're really saying 10 raised to what power gives you 7? And that would be 0.845. So let's fill in 0.845 on our video guided notes. All right, and I think I have one more example. Oh yeah, back to the very first question I asked you in the first video guided. We were saying 2 raised to what power gives you 11. Let's actually figure that out on the calculator. That's log to the base 2 of 11. So that would be control 10 to the x. That's log to the base 2 of 11. 2 raised to what power gives you 11? It's going to be 3.46 approximately, 3.46. So we'll fill that in, 3.46. All right, so now you hopefully are comfortable using, doing logarithms on your calculator. And that brings us to our last topic, which is looking at the graphs of the logarithmic functions. Let's look at y equals log to the base 2 of x. Let's make a few ordered pairs for this, and then we'll pull up the graph on the calculator just to check our work. So if we're doing log to the base 2 of x, let's choose a few values, like what if x is 1, what if x is 2, what if x is 4, what if x is 8. I'm very carefully choosing my x values so that the y's will turn out nice. So if I plug in 1 for x, what is log to the base 2 of 1? Well, remember, that means 2 raised to what power is equal to 1? That's going to be 0. So we have 1, 0. What if I have log to the base 2 of 2? If I'm plugging in 2 now for x, that's going to be log to the base 2 of 2. Remember, that's one of the properties. 2 raised to what power gives you 2? That's the question mark, and it would be 1. So this is going to have to be 2, 1. And what about 4? If I have log to the base 2 of 4, that's saying 2 raised to what power gives me 4? That's going to be 2. How about log to the base 2 of 8? That's if I fill in the 8 now for the x. If I fill in the 8 for the x here, I'm going to have log to the base 2 of 8 equaling something. Well, 2 raised to something gives me 8. That's going to be 3. So I have a few points to plot. Let's plot one more. What about if we have 1/2 as an x? If that's our x value, if I'm going to plug that in, if I'm going to plug in 1/2 here, that's saying log to the base 2 of 1/2 is equal to what? Well, that's 2 raised to what power gives me 1/2? Well, I hope that you're remembering your properties of exponents, because that's going to be -1. So this is going to be -1 here. All right, so if we were to plot those ordered pairs, We're going to plot those ordered pairs. Let's see what they're going to look like, and then we'll confirm it on the calculator. All right, so we are plotting these points. Let's start off with 1, 0, and then 2, 1, and then 4, 2, and 8, 3. And don't forget 1/2 went down to -1. So as a matter of fact, that's what our graph is going to look like, and it's actually going to curve like this. So that is the graph of y equals log to the base 2 of x. So let's take a look at this on our calculator. I need to go to a graphs page, and I am going to type in log to the base 2 of x. And let's see what the graph looks like. There it is. That's what we just graphed by hand. And there's our graph on the calculator. Okay, so that concludes this video. And I hope that you have completed your video guided notes, and we'll work more on this in class. Have a good day.